Okay, this is part 2 of the lesson on 4.3 using congruent triangles. And so what we're going to do in this part of the recording is just go over examples 3 and 4 that you should have worked with your partner or those sitting in your vicinity. Okay, and so we'll use the same approach. We'll start off. What we've been asked to prove is that angle Q is congruent to angle S. And once again, we'll go now to our given information and mark the diagram with any information that we've been given. So we've been given that PQ, segment PQ, is congruent to segment PS, and we also have that line PR bisects angle QPS. QPS, and so that should allow us, if we know what the definition of bisects is, to conclude that angle QPS is cut in half, QPR is congruent to SPR, and then the other information that we can deduce from the diagram is that side PR is a common side. Okay, and so let's begin. We'll start off by restating the information which has been given. Line PR bisects angle QPS, and segment PQ is congruent to segment PS, and both of those were given information. We were then able to conclude that angle QPR was congruent or is congruent to angle SPR, and that is because of the definition of a bisector. And thirdly, we can conclude or deduce that PR is congruent to PR, once again because of the reflexive property. We now have triangle PQR congruent to triangle PSR, and our reason, as you can see from the diagram, is side included angle and side, and we are then able to draw our conclusion if we look. Angle Q and angle S are corresponding to each other. They're corresponding parts of congruent triangles, and so angle Q must be congruent to angle S because of CPCTC, and we've now proved what has been asked. Okay, and the final example for the lesson, same process. We'll start off. What we've been asked to prove is that ZY, segment ZY, is parallel to WX. And so what we're interested in doing is proving parallels. Do keep in mind that we cannot assume parallel in order to prove parallel. This would be a flaw in our logic, and so I'll just erase those parallel markings because we are not allowed to assume parallel. That is our aim in order to be able to prove it. Okay, so we'll begin by marking the diagram once again. We have segment WX congruent to segment YZ or Z. We have segment ZW congruent to segment XY, and once again we have a common side between our two triangles, which in this case is ZX. And so we'll begin by restating what is given. WX congruent to segment YZ, segment ZW congruent to segment XY, and both of those are given. We have segment ZX congruent to segment ZX, and that is because of the reflexive property. This allows us to conclude that triangle WXZ is congruent to triangle YZX. And that would be because of the SSS, side-side-side postulate. And in this particular case, we cannot go directly to the information that we were asked to prove, because congruency of triangles does not necessarily give us parallel lines. And so what it does allow us to do, however, is to conclude that angle YZX and angle ZXW, and again, if we have a look at the congruency statement, that should hopefully be obvious. Y to Z to X and W to X to Z, those angles are corresponding angles, and so we are able to make the statement angle Y ZX is congruent to angle WXZ, and that is because of CPCTC. And this in turn allows us to make our final conclusion that segment ZY is parallel to segment WX, and that is because alternate interior angles congruent. If alternate interior angles are congruent, that implies parallel lines. Okay, and that concludes the final example. And at this point, what you need to do is look ahead to the assignment, which should be detailed on the note, and as usual, start by focusing on the B-level assignment, and all of these are odd number problems, and you should find possible answers in the back of the book.